Good evening. Okay, so tonight we're going to talk about our third and our final method of solving systems of equation, and that is by using elimination. Well, what does it mean to eliminate something? If I'm going to eliminate running from my exercise plan, that means that I get rid of it. I'm eliminating it. It's gone. It doesn't exist. So the first problem that we have here is 3x minus 4y is equal to 10, and x plus 4y is equal to negative 2. So when we talk about eliminating one of the variables, so you want to eliminate one of the variables, you may want to write that down, okay? I'm going to get rid of one of the variables. So I'm going to take this math problem right here, and I'm going to say this is one big giant math problem, and I'm going to draw myself a nice little equals bar down there, and I'm going to solve it out like it's a regular math problem. Here I notice I have a negative 4y and a positive 4y. That's important because a negative 4y and a positive 4y, they make a zero pair and they make 0. So I'm eliminating them. I'm getting rid of them. So I'm just going to use regular addition. So this becomes plus 3x plus x is 4x. That is 0. We talked about that. And then 10 minus 2 is 8. So this is 4x is equal to 8. I eliminated y completely from my equation so I can solve for x. I'm going to divide everybody by 4. X is equal to 2. Now I can take my x equals 2, and I can plug that back in to either one of these equations. I think I'm going to choose this bottom one. X plus 4y is equal to negative 2. I'm going to plug in 2 here for x. 2 plus 4y is equal to negative 2. Subtract 2 from each side. 4y is equal to negative 4. So y is equal to negative 1. And I'm going to write that solution as an ordered pair. So I eliminated 4y. Let's try another one and see if we can eliminate something here. Okay, I noticed I have 2x plus y is equal to negative 5, and 2x minus 5y is equal to 13. All right, well, I've got 2x and 2x, but no matter what, those are positive, so I'm going to get, but I can make one negative, can't I? If I want to make this top, I'll make the bottom one. If I want to make the bottom one, say negative 2x, I'm going to multiply this entire equation by negative 1. So that's going to leave me with, I'm going to keep the first equation, 2x plus y is equal to negative 5. And I'm going to make the bottom, everybody's going to be multiplied by negative 1. Negative 1 times 2x, negative 2x. Negative 5y times negative 1 is positive 5y. And then 13 times negative 1 is negative 13. So now I've created a situation where I have opposites here, or what do we call those, Ms. Sokoloski? Zero pair. They're a zero pair. So 2x minus 2x is nothing. Y plus 5y is 6y is equal to negative 18. And now I've solved really easily for y. But guess what? There is another way to do this.
Okay, now when I look at this problem, I personally see that I have a y here and a negative 5y. So I see, in my mind, I already have opposite signs, so for me it's just going to be easier if I can get that y to be a 5y, because a positive 5y and a negative 5y will eliminate, get rid of each other. So what I'm going to do is I'm going to take my two equations, I'm going to rewrite them here, and I am going to simply multiply that top equation, both sides of it, by a positive 5. The reason that I'm doing that is so that I can eliminate these two things right here, but I can't eliminate it until I do that step. So my top equation is going to become 10x plus, there's my positive 5y that I wanted, and then I get negative 25 over here. Remember, what you do to one side, you have to do to the other. Now my second equation, I'm not changing any. I'm leaving it as is. So now I've created for myself my opposites, my positive 5y and my negative 5y. Those two things get eliminated. That gives me 0, 5y minus 5y. Now when I add these two equations together, I get 12x is equal to negative 12. Then I am going to divide each side, and I get x equals -1. Now I have that. To figure out my y, I plug it into either equation and solve. So I'm just going to take the first equation, 2x plus y equals -5, that original equation, substitute in my -1, and I get -2 plus y equals -5. So my y is going to be equal to -3. Notice how that's the exact same answer that Coach Wallace got over here. It doesn't matter the way that you get there, as long as you end up with the right thing, then that's what we want. So whether you chose Coach Wallace's method of multiplying by a -1 to cancel out the x's, or if you chose the method I showed, which was multiplying by 5, either one will get you the right answer, which is the ordered pair, -1, -3. It's up to you as to which one you choose. Now, final example. Here I look and I'm thinking, what can I eliminate? Well, -5x and the 2x below it definitely don't get rid of each other. The 2y and the 3y, those don't even have opposite signs. Those are both positive, so those aren't going to get rid of each other. So I think I'm going to try and get rid of these first x terms here, because I already have a negative and a positive built into my problem, which is good. Now all I need to do is get the 5 and the 2 to somehow be the same number. So we accomplish that by multiplying each of our equation by some number so that those x terms turn out to be the same thing. So I want you to think to yourself, what number do 5 and 2 have as a multiple in common? Okay, 5, I could multiply 5 by 2 to get 10, and I could multiply 2 times 5 to get 10. So I could get both of these equations to be 10s as my coefficient. So I'm going to do that. I'm going to start here, and I'm going to multiply this equation by 2, the left side and the right side, whereas I'm going to multiply this bottom equation, the left and the right side, by 5 to get positive 10. So when I do that, I get -10x plus 4y equals 64. And then in the bottom, I get -10x plus, oh, I'm sorry. No, I don't. I get positive 10x plus 15y is equal to 50. Now I have opposites. Woohoo! Eliminate those. And I get 19y is equal to 114. Now I want you guys to take it from there. Solve for y, then plug that back into either equation and solve for x. Write your answer as an ordered pair. See?